Hi everybody, are you ready for math? We're going to get started on it. We're going to start something brand new. We'll come back to fractions later on. But right now I want to start something new. So I have a couple questions for you. Look at these up here. No, they're not mystery letters. They're not at all. I want to ask you a couple questions. First of all, which ones would you say are curved? Is this one curved? No, it's pretty straight. What about this one? Yeah, it has a curve in it, right? What about this one? No, it's not curved. Is this? Definitely. That is definitely a curve. So we said this one and this one have curves in them, right? What about the other two? How would you classify those? Straight? Yeah, I would too. Straight, as much as I can draw a straight line, right? Which one of these do you think could be part of a number line? Do you see any of these that could be? You do? Yep. Could this one? What if I took that and put it down here? That would be part of it, right? This one? No, that doesn't fit. That's curvy. How about this one? Yeah, I could make that part of a number line. What about this one? No. No way, right? No way at all. Okay, so I wanted to introduce that to you. And then, of course, you know what this is, right? This is part of the number line, except I don't have any numbers on it. It's just a number line. Do you remember why we have arrows at the end of number lines? Can you tell me? Do you remember that it is because numbers go on forever? Numbers never stop. Even if you get to 0, then you go to negative numbers. And they go backwards for as far as numbers get bigger. Number lines go on forever. That is why we draw arrows on them. So I'm going to teach you a few words that kind of go with this number line. First of all, here's this easy one. It is the word line. This is a line. There's no numbers on it, so we just call it a line, right? What if I took part of this line and pulled it out? Those dots on there, do you think those dots mean anything? Yeah, they do. Those dots mean it's part of the line. Those are kind of like stop signs. If you see dots at the end, they're stop signs. We call this a line segment. A line segment. You may have heard the word segment in talking about insects. They have different segments in their bodies, different parts of them. This is a part of a line. We call that a line segment. This is a line. This is a line segment. Does the line have to be this long? Nope. Does this line have to go straight horizontally? Nope. Guess what? This is a line. You know what else is a line? That way. It doesn't matter. You can make it go any direction. If it has arrows on the end, we call it a line. So what about a line segment? Can I move that in any direction? Yep, you betcha. I can. I can move that in any way. And if it has the dots on the end, we call it a line segment because it is part of a line, right? Okay, so let's mix it up a little. What if I have a dot and an arrow? Ooh, there's a name for it. You want to know what it is? It's called a ray. Have you ever heard of the sun's rays? If we have a sunshine here, the sunlight is coming in every direction, isn't it? The rays from the sun, they don't actually have real arrows on the end of the sunbeams that are coming down, but they're called rays. Do you think rays can go in any direction? Yeah, as long as one end is a dot and one end is an arrow. Do you want to know what else? Look what else you can do with a ray. You can have more than one ray coming from the same dot, and they can be different lengths. Today we are going to start a big group of math, a new thing in math, and we call this Can you guess? Geometry. Shapes. You guys know some basic shapes already. That part should come pretty simple to you. It should. Geometry is the study of lines, angles, shapes, things like that, and how they're used. So we're going to start this fun part together. Would you please open your hardcover math book, the one with the hardcover. Open it to page 304. 304. At the very top of it, it says 9-1, and then it says lines. L-I-N-E-S, lines. They're at the top of the page. Let's look at this together. Here are the things we just learned about lines. Okay, the first one says a line is straight. It is a set of points that extends forever in opposite directions. In any direction, both sides. They give examples. And then look at the line segment. It's the part of a line between two endpoints. Those stop sign dots, we call those endpoints. Think about that word. That makes sense, doesn't it? The endpoints, because they're points that say this is the end. You can't go any farther. Endpoints. And then the bottom one is a ray. A ray is the part of a line that starts at an endpoint. So it starts where the dot is. And then it goes on forever in one direction. But you can have more than one ray, okay, coming from the same endpoint. Let's look at the practice at the bottom of the page. It says name each. So we can either choose line, line segment, ray, or none of these. They're going to try to trick us, but you guys, I think, are smarter than that. Let's look at number 1. In your head, I want you to figure out what you think number 1 is. I see an endpoint and an arrow. That means that this particular line starts in one place and goes forever in one direction. Do you remember what that's called? A ray. Good. I hope you got that. That is a ray. Everybody look at number 2. Oh, I see arrows on both ends. What do you think that is? Oh, that's just a regular line. Yep, it is just a regular line. Look at number 3. What do you see at the ends of those? I see little endpoints, little stop signs. What do we call that kind of a line? It's a line segment. Look at number 4. Do you notice something weird about that? What do you think the answer is? Is this a line segment, array, or none of these? Yeah, that's none of them. That can't be because it's curvy. Lines aren't curvy unless it's a curvy line, right? But a line, like we've done here, they are straight. So you can't have them curvy. So number 4 is none of those. It's not any of them. Look at number 5. Oh, well, even though it has endpoints at the end, I notice that this is not straight. So can that be one of our 3 types of lines we've learned? No, it's none of these. Look at number 6. Oh, okay. All right, so I see arrows on both ends, and it's a straight line. So if arrows are on both ends, what is that called? A line. Yep. Look at number 7. Okay, I see 2 different ends. I see an endpoint and an arrow. Do you remember what we call it if there's an endpoint and an arrow? That's a ray. Okay, number 8. Oh, here's the same deal again. They're trying to trick you. What do you think this one is? It's none of them. The reason it's none of them is because it's not a straight line. You can't have a line have curves in it like that for it to be a regular geometry line. Okay, so first thing we've learned is about a line. It goes forever both ways with arrows. A line segment, it has dots. And then a ray has one of each. All right, good job. Now I want you to take a look at the next page. We're going to talk about this. We're going to talk about how lines act sometimes. Lines can do different things. Look at the top of 305. These are special lines. They've got some big names, so pay attention. There are 3 words, 3 phrases in yellow. We have intersecting lines, parallel lines, and perpendicular lines. Big words, but they're still fun. And then I see what looks like a street map. Do you see that in your book too? Looks like a street map. The big street is called Main Street. And then there's 3 other streets that cross them. Green Street, Birch Street, and Linden Drive. Okay, so we're going to have to do something with those. But first, let's look at intersecting lines. Intersecting lines are lines that meet at a common point. They cross each other, okay? Intersecting lines. So I'm going to draw a line here, and I'm going to draw a line here. Do they cross each other? They're intersecting. Intersecting lines cross at some point. Let's see. What about those? They're lines and they cross, so they're intersecting. Let's try this one and that one. Do they cross? Then they are intersecting lines. Remember, intersecting lines are lines that cross. Have you ever been riding in the car and you have come to an intersection of the map where 2 roads cross? That's an intersection. Those roads are intersecting roads. That's where we get that line from, okay? Or that word from. Intersection is the root of intersecting. So intersecting lines are lines that cross. Okay. The next one, parallel lines on a flat surface that never intersect. Okay. Parallel, P-A-R-A-L-L-E-L, lots of L's. Parallel lines never, ever, 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 ever will cross. Doesn't matter how far out they go. They will never cross. Those are called parallel lines. They can go this way, they can go this way, this way. It doesn't matter. If they don't ever touch, they're called parallel lines. Question, can parallel lines also be called intersecting lines? Nope. Intersecting lines cross, parallel lines don't. Can parallel lines ever be called, I'm sorry, let me say that again. Can intersecting lines ever be called parallel lines? Nope, they can't. Intersecting lines cross, parallel lines don't. Okay? Now, the third one they're going to throw in there. It's going to be a little trickier, so pay close attention. Put on your thinking caps. Let's look at this. Perpendicular lines. Kind of sounds like purple, but it's not. Perpendicular. Everybody try to say that. Perpendicular. Perpendicular lines are lines that intersect at square corners. Okay, guys. Perpendicular. They have to be like a square. I'll show you what I mean. Perpendicular lines must cross like a square. Do you see how in the corner here, there's a square? If I can draw a square and it touches the lines correctly, those are perpendicular lines, okay? They can also go in this direction. It doesn't have to be just straight up and down, but if they cross and the corners are squares, those are perpendicular lines, okay? Are these perpendicular lines? Nope, they're not. You're right. This is not a square. That's a diamond. Same with this one here. That's not a square. They have to be squares, okay? Perpendicular lines are lines that cross and they have squares in them. All right, now let's do this here. Can perpendicular lines be parallel? No, they can't. Perpendicular lines cross, don't they? Parallel lines don't cross. Can perpendicular lines also be intersecting lines? Think about that. In order for it to be an intersecting line, it has to cross, right? Do perpendicular lines cross? Yes, they do. This right here has two different names. These are intersecting lines because they cross, but they're also perpendicular lines because they have squares in them. You can have both intersecting lines and perpendicular lines. But let me ask you this. Is every intersecting line a perpendicular? Are they perpendicular lines? Nope. Because like these are not squares, right? Those are diamond shapes. These are not perpendicular, but they are intersecting because intersecting lines cross. The only requirement to be intersecting lines are that they cross. But if they're perpendicular, they have to have squares in them. So be very careful about that. Some are called both intersecting and perpendicular lines. Pretty cool. Let's look back at your book. Up by the special lines, we have the street. Right under that box, it says, using the street map above, answer these questions. Number 9 says, name 2 streets that are parallel. Quick review. What's parallel? They never cross. So let's look at our map. Well, I'm just looking, going across Green Street and Birch Street. Would Green Street and Birch Street, do they cross here? No, they don't. So we would say that they're parallel because they don't cross. What about Birch Street and Linden Street? Do they cross? No, they're parallel. Well, what even about Green Street and Linden Drive? Do they cross? No. So they are parallel lines. And then number 10 says, name 2 streets that are perpendicular. Perpendicular is like this. It makes a square. Okay? Have to be square. Can you see 2 streets that cross? And when they cross, they make a square in the corner? I do. Look at the Main Street. Main Street is perpendicular to all of them. Green Street and Main Street are perpendicular. Birch Street and Main Street are perpendicular. Linden Street and Main Street are perpendicular because they cross. Okay? Intersecting, any kind. So you can do this with your fingers. Intersecting means they cross in any way, right? Parallel, they never cross. Perpendicular, they have to be straight squares, like they have to be squares, okay? Like a cross would be. So perpendicular, intersecting, parallel. That might be a good way for you to remember it. All right, so what we're gonna do now is I want you to look at your math paper. Take out your math paper, and I'm going to get that, and we're going to talk through that together. So take it out, page 111. So on page 111, it looks like lines like this, except mine has the answer, so I'm not going to tell you. All right, page 111. At the very top, it tells you the things that we've been learning. And then on 1 through 8, it wants you to write what it is. A line segment, array, or none of these. 1 through 8, you need to do that and write what it is. Be very careful. Every year I end up with people getting confused on those. So really look carefully at the top and compare them. On the bottom part, it says draw a line that is parallel to the line. So if the line looks like this, then you're going to draw one going exactly the same direction. That's parallel, okay? Number 10 says draw a line that intersects the line. What does intersect mean? Crosses. So any line that crosses the one given is fine. And then number 11, draw a line that's perpendicular. Perpendicular, remember, they have to be squares. They have to cross like a cross in order for it to be perpendicular. You're going to go ahead and draw a line that crosses that one. When you're done with that, you're done for today. Happy mathing. I'll see you tomorrow.